So we're working on 5.5, solving rational equations. And I want you to go through these 6 problems with me. This is going to be great for you to do, and anytime, pause, try to work it out, and see if we get the same answer. That's the goal here. All right, here we go. First one. Okay, so I see all of this stuff. My first goal, this is what I kind of talked about in the other video, was I want to get a fraction equal to a fraction so I can cross multiply. So over here on the left side, we're looking good, right? Just a straight up fraction. On the right side, I don't like that because it's not just a straight fraction, it is a stuff. So let's get the stuff to be one single fraction, okay? So how do we do that? Let's just multiply the bottom by 3 and multiply the top by 3. That's going to give me a 6 on the bottom, because if I have a 6 and a 6, then I can add these things together, right? So let's do this. So on the top, we get 1 plus 3 times 1, which is 3. So that's going to give me 4 over 6, right? That's going to give me 4 over 6 is equal to, and we're going to keep this side the same right now, and it looks like that. Okay, now that you get a fraction equal to a fraction, we can cross multiply. So cross multiply looks like top of one times the bottom of the other. So we're going to go 4x equals, now this is a group x plus 4 on the top. So make sure when you multiply the 6 times the x plus 4, you distribute that across. So you can do that all in one step if you'd like. And so that's going to be 6x plus 24. All right, now we're solving like normal. Subtract 6 from both sides. 6x, sorry. That goes away. We've got negative 2x equals 24. Let's divide by negative 2, and we're going to end up with x is equal to negative 12. Okay, so here's my answer, but we need to double check. Is this answer going to produce an undefined value? Nope, because the negative 12 on the bottom of a fraction does not create an undefined value, so we're going to be okay there. Okay, so there we go. All right, let's try the next one. Okay, so I can see again that I don't have a fraction equal to a fraction. I have a broken up fraction, right? So here, and so what I want to do is try to squeeze that together if I can, or if there's a way to move this over and not create a broken up fraction, that would be good too. So just adding 5 over r to both sides is not going to be helpful. So I'm not going to do that. But what I will do is let's get like denominators here. All right, multiply by 4. Now we got 4r and 4r. So this is ready to go. Okay, so if we got the same, here's what we're going to have. So on the top, I'm just going to write this out first. R plus 2 minus 4 times 5 minus 20 over 4r equals 1. Okay, so we're there. Let's just reduce a little bit. R minus 18 over 4r equals 1. Now, I want to make this a fraction equal to a fraction because I want to be able to cross multiply. So now we have the option to cross multiply. 1 times 4r is going to be 4r is equal to 1 times r minus 8 as a group. Now, distributing a 1 across a group is not going to change it, so it's just going to be r minus 18. All right, so that's what that looks like. Let's get our r's on the same side, so subtract r from both sides. So now we got 3r is equal to negative 18, and divide by 3. Divide by 3. R is equal to negative 6. There we go. Okay, but what do we need to do? Check, is negative 6 going to produce a problem here? Nope, it's not going to make it undefined. Is negative 6 going to produce a problem here? Nope, not undefined either. So r equals negative 6. That is my solution. So just real quick, here's what we're talking about. Extraneous solutions, this word extraneous solutions, is if I get a solution and it makes an undefined product. That we call it extraneous, which has the word extra. So it's extra, but it doesn't actually apply to the problem. Okay, so that's what it sounds like. All right, let's do 4 more together. Okay, what am I going to do here? There's the same thing that I want to. I want to get a fraction equal to a fraction. I think I'm just going to go right here. I'm going to go multiply that by 2. So the whole top group needs to be multiplied by 2. Okay, so then I'm going to end up with 1/2 equals, now I can put all the top together, and I'm going to distribute this as I do that. So it's going to be 3 plus 2r plus 2, right? There's that distribution property all over 2r. Okay, let's keep going. 1/2 is equal to, I can put the 3 and the 2 together, so I'm going to have 2r plus 5 over 2r. So here's something, be cautious, do not, and I tell you, some people see that, they're like, oh, those cancel. They do not cancel because this is a group on top and that is not a group on bottom. So we cannot cancel those. So now we got to rely on our old-fashioned cross multiply. 1 times 2r is 2r equals 2 times the group 2r plus 5. So we're going to need to distribute that 2 across when we do that. So it's going to give me 4r plus 10. All right, here we go. Negative 4r, negative 4r. So I get negative 2r is equal to 10. R is equal to negative 5 divided by negative 2 on both sides. R is equal to negative 5. That's going to be my answer unless it doesn't work, right? Unless it's here, it's not going to create a problem. Here, it's not going to create a problem, right? It's not going to create a 0 on the bottom. So we're good, negative 5. Next one, ooh, x squareds. Yikes. It's okay, we're going to get this done. Here we go. Let's get common denominator so I can get a fraction, a solo fraction on the left, solo fraction on the right. So that's going to give me 6 plus the group x minus 6 over 6x squared equals x plus 3 over 6x. All right, so let's reduce. Oh, a positive 6 and a negative 6. I like that. X over 6x squared is equal to x plus 3 over 6x. So now I can cross multiply, or let's help ourselves out a little. Check this. So I'm really going to zoom in. So you got 2 parts, right? You got the left side, the right side. Look at the left side. What if I cancel the x with one of the x's that's in the x squared to just leave me with a single x? Why would I want to do that? Because it's going to make life easier, and they're both outside of groups, so that can happen. So that's just going to be a placeholder of a 1 on the top, x on the bottom with the 6. Now, don't be tempted to do this. That's not a thing, because this is part of a group, and down below it's not part of a group. So do not be tempted to do that. Okay, I'm going to rewrite real quick just to squeeze this up a little bit, is equal to x plus 3 over 6x. All right, here we go. Cross multiply. 1 times 6x is 6x. 6x times the group. So make sure when you take that 6x, you distribute it. So that's going to give me what equals 6x squared plus 18x. All right. Now, if you see a squared term, this is called a quadratic. In order to solve quadratics, the way we've been solving quadratics is get a 0 on one side. Okay, so let's subtract 6x from both sides. So I get 0 is equal to 6x squared plus 12x. Okay, now I always want to think factoring when I'm trying to solve this. Is there any greatest common factor between a 6 and a 12? Well, you bet there is. There's a 6. And what about x squared and x? You bet there is. There's an x. So that's going to, if I extracted that, it's going to leave me with x plus 2. All right, so what are my two answers? Either 6x equals 0, because that would give me a problem, or the group x plus 2 equals 0, because that would give me a problem. So literally set these equal like this. So either of those groups, so x is equal to 0 if I divide by 6 on both sides, or x is equal to negative 2 if I subtract 2 from both sides. So I get two possible answers here. Okay, so now what do we need to do? Go back up to the original. If I plugged a negative 2 in here, or here, or here, would it create undefined fractions? No, it wouldn't. What if I plugged a 0 in here, here, or here? Would it create undefined fractions? Absolutely, it would create an undefined fraction all the way across that. So we are going to say that 0 is extraneous, or not an appropriate value. Only negative 2 is. All right? All right, let's do a couple more. Oh, boy, this got ugly. All right, let's see what we can do to try to eliminate this. So the first thing I'm saying is I got k's on the bottom of these two things. That might be okay to, like, let's subtract a k and get it over on the other side. So that's one thing I could do, or I guess technically I could multiply everything by k, every single thing, right? So I'm talking about this by k, this by k, this by k, and this by k. If I multiply them all by k, I would eliminate the k's that are on the bottom, right? So that could be a cool way to do it. So what if I multiplied by k, like this whole thing, k would cancel with the k, multiplied by k, because if you do one, you do it to one side, you got to do it to everything on both sides. Multiply by k, the k's cancel here. Oh, that's kind of a cool way to do it. What do you say? That we got 4k squared plus 40k plus 100 is equal to k times k here is going to give me k squared plus 2k and then plus 1. All right, well, that got us somewhere, I guess. So let's subtract k squared from both sides, because anytime I see a squared, I want to get all that together. Let's also subtract 2k, and let's also subtract 1. Okay, so that's going to give me what? 3k squared plus 38k plus 99 is equal to 0. Now here's what I'm going to do. I'm going to see do all of these factor by 3, because if 3 is the greatest common factor, that would be super awesome. I know 3 and 3 are. What about 38 divided by 3? It's 12.6. It's not a factor of 3. That's no fun. Okay, well, that was a good shot to try. Okay, so here's what we're going to do. We're going to see if we can factor these things. So I am going to multiply these two together. So I do a technique called slide and divide. Remember, slide and divide is k squared plus 38k plus 99 times 3, 297. I'm going to try to find two things that multiply to 297 and add to 38. So 297 divided by, let's try some numbers, 33 and 9. Nope. 297 divided by 20 something. No, just going to try a few more here. 33 works, but 33 and 9 just don't. They're not 38. Hang on, I'm just literally dividing this by different numbers just to see if I can find something that works. So 11 and 27. 11 and 27. There it is. Right? So 11 times 27 gives me 279, but it also adds to a positive 30. So then I would go k plus 27, k plus 11. But then a slide and divide technique asks you to bring the 3 back down, divide these by 3, and then we're going to clean it up. So this is kind of an unorthodox method, but it works every single time. So 3k plus, oops, I don't want to do that. Let's clean these up real quick. K plus 27 divided by 3 is 9. K plus 11 over 3. Okay, so anytime that you're left with a fraction, you're going to slide that right in front. So here's what it actually is. K plus 9 times 3k plus 11 equals 0. All right, so now we're at this point. So same rules always apply. If this group equals 0, then the whole thing equals 0. If this group equals 0, the whole thing equals 0. So we're going to get k plus 9 equals 0, or 3k plus 11 equals 0. So subtract 9, so k equals negative 9. Subtract 11, 3k equals negative 11. K equals negative 11 thirds. Right, divided by 3 at the very last part. All right, if either of those going to give me problems in the original equation. So negative 9, there, nope. Negative 9, oh, that's not going to create a problem. There, nope. And then the other one, nope. So both of these are legit answers here. All right, last one. Here we go. Okay, so same rules apply here. I want a fraction equal to a fraction, or can I get rid of things, right? So what if I multiplied everything by n, right? So again, because I'm always looking like for this and this and this. Actually, 4n would probably get it done. But let's just say I don't want to go that route this time. I just want to combine two fractions together like this. So if I was going to do that, it looks like I just need to multiply this by 2 That means the top group would also have to be multiplied by 2. And so then I'm going to do 2n squared plus 6n plus 4 over n. So that's what's on the left side. On the right side, since this, now I'll distribute this across this whole thing. But it's going to be a lot of junk over 4n. So it's going to be 1 plus 8n squared plus 42n minus 36. Okay, we can combine like terms, which is the positive 1 and the negative 36. So with this one, 2n squared plus 6n plus 4 over n is equal to 8n squared plus 42n minus 35 all over 4n. So sometimes you just like it's nice to try to factor now, or we can factor later. So either way, it's gonna be the same idea. But this is a huge, big, ugly problem. We just want to be able to work through big, huge, ugly problems. So we got to stick with this. You're really going to need to be good with factoring when you do this, okay? So here you're going to have 4n times the group 2n, and I'm actually not going to distribute it because I'm going to end up factoring at the end of the day. Well, actually, I do want you to distribute because I'm going to have to pull all things together. So let me just go ahead and distribute. So I'm going to go 8n cubed plus 24n squared plus 16n equals, let's cross multiply here across that one, 8n cubed plus 42, it's not a 2, 42n squared minus 35n. Okay, so now what I'm going to do, let's just start putting things together. So let's subtract 8n cubed from the right side, subtract 8n cubed from the left side. Well, that was nice. On that. Okay, so let's keep going. Let's try, how about we do subtract 42n squared from the right side, subtract 42n squared from the left side. Well, what's that going to give us here? Even if we need to, 24 minus 42, right? That's negative 18n squared. Okay, so that took care of that piece right there. And then let's add 35n over here. So we're going to add 35n over here. So we're going to get plus, if we do 16 plus 35, 51n is equal to 0. And why did I want to get a 0? Because we're dealing with a squared term, right? But now it makes it a little bit nicer. Let's see, does 51 divide by 3? It sure does. So I think I can take a negative because this first one's negative. I'm going to take a negative 3n out. That's going to leave me with 6n minus, and I took 51 divided by 3, and it's going to give me 17 equals 0. So here we're at the call to do this negative 3n equals 0, or 6n minus 17 equals 0. Both of those are going to give me answers. So n is equal to 0. There's one answer. Let's add 17 to both sides. Let's divide by 6 on both sides. And we have it. Are either of those going to give problems? You bet. This 0 right here is going to give a problem there, and there, and there. So the 0 is what we call extraneous. And then so 17 over 6 is my final answer.